Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals, right? So here we have to evaluate this integral that is from 0 to pi, and we have here x times sine cube of x, right? So we have to solve this integral, and let us call this integral as I, right? And we can take it as integral number 1, right? Okay, now before solving this integral, let us take a close look at this integrand, right? Now see here we have the integrand, that is x sine cube x, right? So at first glance we see that this is the product of two functions, right? So x is the algebraic function, and the second function is the trigonometric function, right? And we can conclude from this analysis that we should use the method of integration by parts, in which we integrate the product of two functions, right? So this is the algebraic function, this is the trigonometric functions, right? But here we are not going to use integration by parts, right? Because see, if we use integration by parts here, then this would be a very lengthy process, right? So this is left as an exercise for you to find out the value of this integral using the method of parts, right? So here since this is a definite integral, so we are going to use the property of definite integral to solve this integral, and we'll see how easily we can solve this integral by making use of this property of definite integral, which says that suppose we have the integral from 0 to a f of x dx, then we can apply this property, that is 0 to a, and we have f of a minus x, right? So simply what we do in this property, we replace the variable x by a minus x, right? And using this property we can simplify the integral, right? So here we are not going to use the method of parts. So let us apply this property to this integral, right? So if we compare this integral with this one, that is 0 to a f of x dx, then we see that the value of a, that is the upper limit, is pi, right? And f of x is the product of x and sine cube x, right? So what we will do, we'll replace this x by a minus x, right? So here in this problem we'll replace x by pi minus x, right? So our next step is I is equal to 0 to pi, and we have for x we can replace pi minus x, and then we have sine cube, and here also we have pi minus x, right? So wherever we have x, we'll replace x by pi minus x, right? So here now we have sine of pi minus x, and from trigonometry we know that sine of pi minus theta is simply sine of theta, right? So now I can be written as 0 to pi, and here we have pi minus x, and sine of pi minus x is equal to sine x, so here we have simply sine cube x, right? Okay, so now what we will do, we'll multiply these two terms by sine cube of x, right? So we'll have 0 to pi, and here we'll get two integrals. So the first one is pi times sine of cube x dx, and then we have minus 0 to pi, and we have x times sine of cube x, right? Okay, so now this integral is reduced to this one by making use of this important property, right? Now we see that this integral is our original integral, so we can replace it by I, right? So now we have 0 to pi, and we can take this pi outside the integral, being a constant. So we have here sine cube x dx, and here we have I, right? So this integral is our original integral, so we replace it by I, right? Now we can take this I to this side, so we have I plus I, that is equal to pi, and we have 0 to pi and sine of cube x dx, right? So this is now I plus I is 2I, so now we can write I is equal to pi over 2, and we have 0 to pi sine cube x dx, right? So viewers, the original integral in which the integrand was a product of two functions. Now see, here by making use of this property, we have reduced this integral to an integral in which the integrand is a single function, right? That is sine cube x. Now we can easily integrate sine cube of x from 0 to pi. So now we can write I is equal to pi over 2, and see, here we have 0 to pi, and now sine cube x can be written as sine square x times sine x, right? So here we can also apply the identity for sine cube x in terms of sine 3x, right? But here we are not using the identity for sine 3x. Instead, what we will do, will break sine cube x as a product of two terms, that is sine square x and sine x, right? So now we have pi by 2 here. This is 0 to pi, and sine square x can be written as 1 minus cos square x, right? Okay, so now we have this integral. And see, now we can here use the method of substitution by taking u is equal to cos of x, right? Because the derivative of cos x is minus sine x, right? And sine x appears in the integrand. So now we have du over dx is equal to minus sine x, and du is equal to, or minus du is equal to sine x dx, right? Okay, now see, we are here changing the variable from x to u, and x varies from 0 to pi, right? So let us first change the limits, right? So when x is 0, then u is cos of 0, because here we'll take x is equal to 0, cos of 0 is 1. When x is pi, we have u is equal to cos of pi is equal to minus 1, right? So now I is pi over 2, and we have the limits from 1 to minus 1. Here we have 1 minus t square, here we'll have the variable u, so we have u square, and for sine x dx we can write minus du, right? So now we have a very simple integral here. So we have I is equal to pi over 2, and we have 1 to minus 1, and here this negative sign, we can interchange these two terms. So we have u square minus 1 and du, and we have pi over 2. The integral of u square is u cube over 3, and integral of 1 du is simply u, right? Okay. So here we have used the important result, that is integral of x raised to n dx is x raised to n plus 1 over n plus 1, provided n is not equal to minus 1, right? Okay, so now we can simply substitute the limits, and here we can first take minus 1. So minus 1 cube is minus 1, over 3, and when we take u is equal to -1, so this becomes +1. Then we have here u is equal to 1, so 1 cube is 1. This is 1 over 3, and here we have simply 1, right? So now we have pi over 2, and here we have 3 ones are 3, 3 minus 1 is 2 over 3, and here we have minus 2 over 3, right? So now this is pi over 2, and here we have 2 over 3, minus times minus, this is plus, so we have 2 over 3, and this is pi over 2 times 4 over 3, and here this is 2 2s are 4, so this is 2 pi over 3, right? So the value of this integral is equal to 2 pi over 3, and see how we can easily solve this integral by making use of this property of definite integrals, right? So this is how we can solve these type of problems.